Hey everyone. So as you can see, we've got an assortment of tractors here, and the objective is to get a few data points on power. Now, if you are following the channel, you have already seen the turbo encabulator, but we've made some changes. I'll go through the changes, and then I'm going to bring you up to speed on my slightly updated methodology, and then we're going to run the tractors and see what. All right, so I tried to cut this up a few different ways. I think having 4 tractors in one video was probably a little bit ambitious. So I'm going to go ahead and do a different format, a lot more voiceover. I'll show you the important bits on video, but I think this is going to make a cleaner, shorter video that will be a little more enjoyable. And at the end of the day, what we're really trying to do is demonstrate how much horsepower you're going to get out of the HydrosPlus Turbo Plus tractor, but I wanted to add a few data points in just to make sure people felt comfortable with the approach. Now, if you watch the previous video that I did, I mentioned the turbo encabulator. If you haven't Googled that, and go ahead, you'll be in on the joke at that point. But I mentioned in the previous video that we don't actually care about what the horsepower is. We just care about how much increase we're going to get. And the reason I did that is because I really didn't want to answer a lot of questions about why was the horsepower too low or too high or whatever it might be. Now, that said, I was doing it on a single tractor previously, and the idea was I would just take one tractor, return it to stock, run it, put the Turbo Plus on, open up the fuel, and then run it and compare the same tractor to itself. In doing that, because I had already taken the fuel screw, it had actually come out on me, I wasn't real confident that I was getting exactly back to the point that it was when it was stock. So I had a local customer, reached out to him. He was gracious enough to let me borrow his tractor for a day or two, and now we have a stock specimen to compare to the HydrosPlus Turbo Plus. Sure, it's not the same tractor. There will be some slight variations potentially, but really we're just looking for a directional number. And again, how much is it increasing? So use that percentage. It doesn't matter how much you start with, you're going to get about that much increase. Now, all that said, I did do a little more work in the background around the methodology, and I changed the coefficient that I was using to pressure times volume times 0.0007. Now, those of you who are familiar with hydraulics, you've seen other videos, the number that you may have seen, or the equation you may have seen, was pressure times volume divided by 1714, and that is accurate, but the exception to that is there's an additional step when you're trying to calculate hydraulic horsepower where you need to input the efficiency, because if you assume that it's 100% efficient, depending on what you are trying to determine, like we're doing this a bit upside down from what those traditionally try to do. Those equations say how much horsepower does it take to turn this motor, and we're flipping it saying this motor is expending how many horsepower to create the pressure and the volume. So if you're curious or you want to kind of spot check the math on this, if you take the numbers that you see here and you multiply pressure times volume divided by 1714, and then take that product and times it by an efficiency, which for most gear pumps or gear motors, we'll use 80%. That's what we're going to use here. And that translates to the 0.0007. So that's why you see me using that. So this is going to be pretty much the closest approximation to actual horsepower that we can get. Of course, we didn't go and check this gear pump to see if it was 80% efficient, 75% efficient, or 85% efficient. So we're just going to use kind of a standard 80%. That's That's what I see it most of the time in the papers I read and other places I've seen on the internet when they're doing these types of equations. So that's a little bit different change, bit of a change in methodology. Now, the other thing I want to mention is when I did the first video, I was using a pump that was rated at almost 21 gallons per minute at 540 RPMs. In the case that we had, I only have a 20 gallon per minute flow meter, so I wasn't actually able to see what the horsepower was at 540. I could pull it down to about 480, so that could put me at 20 gallons per minute, and then calculate the horsepower there. It turns out that that's actually probably where you're going to get a higher horsepower reading anyhow. So we ended up doing that. But in order to make sure that I was in the range that I wanted to be in, I went and got a different pump that's only that's supposed to put out about a little over 16 at 540 RPM. So on my gauge, it was showing about 17 at 540. So that's what I use for the Kubota. It doesn't have an RPM gauge for the PTO, so that's what I use to determine actually what the PTO RPMs were. All right, last thing I'm going to say on this, we'll call it a dyno uh, I called it intentionally power comparison apparatus because I did not want to get into the conversation around how much horsepower. Now, I have adjusted my methodology so that I do believe that these horsepower numbers are pretty close. If we wanted to get them closer, we would need to test the efficiency of the pump, and we'd also need to make sure that our gauges have been recently calibrated. This one is actually new, so it should be in calibration, but if you really wanted to try to get down to a dyno level readings, you would want to have things like that, as well as your pressure gauge being recalibrated just to make sure everything is good. Now, if you're following along and you're interested in a turbo for a 1025R, most likely you've seen the one that Tractor Time with Tim has. He's had it for I think a year or maybe just a little bit more than a year. And he actually now has HydrosPlus Turbo Plus on his tractor. Now, whether he's going to keep that long term or not, I'm not really even worried about that because at the end of the day, the differences in the two, the one from Area Diesel and the one that we have, really I don't think they're going to be that much. But I do want to call this out because the numbers that I'm getting are much lower than what they saw on their dyno. And I think the reason for that is, well, there's probably a couple of reasons. You notice the guy that runs it, I think he's run both dynos. I think they have a couple of them because they have a local tractor club. And he does mention that it's probably within about 5 horsepower, maybe 10 horsepower. Now, I don't know what the guts of this particular dyno is, but I think it is virtually the same as what we have here. The difference is it is likely calibrated to a particular flow. And if you do that, then as he turns the wheel, he's adding pressure, and the gauge on there, the more pressure you get, the more horsepower. The thing that he doesn't have the ability to read is how much that flow is going down once you go below 540. And so as you lug it down, the numbers are going to get less and less accurate. At 540 though, I think it's probably pretty close, and even then, I got some different numbers than they did, at least just watching the video, trying to determine when they were making a measurement at 540. But that really doesn't matter. Again, what we're trying to do is compare what the horsepower is and how much percentage gain that we're getting. But it does make me feel a little better when the numbers kind of line up, at least with a website or something that we know, um, because that helps. But again, if we started and we said that the tractor had 3 horsepower, or if it had 30 horsepower, doesn't matter because the gain of 10, 15, 20, 30%, whatever it is going to apply just the same. We're jumping in here midstream with the Kubota. I've already got the fluid warmed up. I've got all the power comparison apparatus connected up. And as you can see here, I'm actually backing it off just a bit so that I can run it down. I didn't want to have to uh, make it work its way up. So from going higher RPMs and then slowing it down to get a reading. And with the Kubota, it was a bit surprising, and we'll come back to it after. This is the first one that we run, uh, and the number was a little bit lower than expected. I think I end up, you'll see, I'll pull out a calculator here. It turns out nobody keeps a calculator around anymore since we all have one on our phone. And uh, here I'm actually recording this with my phone, so I have to use another phone, but there it is. And it does have the case on it, so it's kind of slick. But I mentioned earlier we're going to do volume, which was 17 gallons per minute times 1300 psi. You know, it kind of bounces back and forth. I just take a good approximation. That's 22,100 when times it by point zero. Oh, I gave it the benefit of the doubt. I said 1325. So 22,525 times 0.0007, and we got 15 and 3/4 horsepower. Now, when I looked on the website for Kubota, this should have gotten, you know, in the 17. Actually, I think it was right the same as the 1025R. So it's a little confused as why that one was lower. Now, again, we're going to come back to this. I'm showing here if you went port 0008, which means that the pump is a little less efficient. This is the first one I'd done, so I was kind of playing with it just a bit. But again, we'll stop here on the Kubota and we'll jump back to it here at the end. All right, jumping in on the borrowed stock 1025R, and just getting the final adjustments here. But it did show more horsepower. So 1450 was the pressure at 17 gallons per minute. So times that by 0.0007, and I got 7.25. And interestingly enough, on the website for John Deere, they say the PTO horsepower is 17.2. So that's right on, of course, but it seems a little. I wouldn't say that that means that the dyno is perfectly tuned in or anything like that. But a couple of things, because naturally, I think I wanted to say, okay, well, if this one's right, then does that mean, or if I think it's right at least, does that mean that the Kubota really has a lot less? Don't make fun of my broom here. I parked the tractors too close together and couldn't get in between them. But the one thing I would mention about the Kubota is it only has a 0.9 liter engine. The 1025R has a 1.3 liter engine. Now the 1023 has a 0.9 liter engine as well. And so maybe they're more comparable. So 1785, so that was actually me pulling it down to 15 gallons per minute. So while the gallons per minute went down, the pressure went up enough that it was actually a net gain. So it was putting out, you know, well, actually, I had to do the math. I didn't actually look at what the RPMs were. It was probably somewhere around 450, 480, but we ended up with a little more horsepower squeaked out of it with, you know, the governor wide open and it lugging. So, and that's what I was mentioning earlier about this method versus the one that you saw on the dyno with Tractor Tom and Tim. If we would have done that lugging without knowing what the actual flow reduction was, we would have done 1700 times 17, which would have ended up at 28,000 times 0.007. So we would have thought it had a little over 20 horsepower when now that we have all those variables, we know it's about 17.8. So 17.8 is the max horsepower. At 540, we got 17.25. Now we'll jump over to the HydrosPlus Turbo Plus. All right, on to the 1025R with the HydrosPlus Turbo Plus. Now, the reading I got here, I'm not saying it's wrong, but at the time I was doing it, it was a little bit puzzling. You'll see that it's a little bit lower. Now, one hypothesis is right now I've loosened up the screw, but I ran the power up to PTO, And as you can see here, I was already pulled down below 17. And when I adjusted it, I went up. I didn't go up above it and then pull it back down. So I don't know if that played any factor into this. Um, the other thing I would say is, and we'll jump to the 2038R here in just a minute, but it actually gets a lower than expected reading, much lower than expected reading at 540. But when we lug them down, you'll see here shortly that we actually get a whole lot more horsepower. So right here at 540, I'm only showing that it's 15.47, which is, I'm pointing to the Kubota. Hey, that's very close to what that one got at 540. So you can't hear this because I'm doing the voiceover, but my mind immediately was like, oh, I want to go back and do the one on the Kubota and see if I could figure out like what is the nuance here. But with that, I went ahead and did the test where we pull it down to 15 gallons per minute, and we see a significant increase in horsepower. Here we are getting started with the 15 gallon per minute, so pulling it down and letting it labor. Now, with any turboed engine, you're not going to get the most boost until you actually labor the engine. You can run wide open throttle all day, and on this HydrosPlus Turbo Plus, you're going to run about 2 to 3 pounds of boost without laboring it. You put this down, as you'll see here shortly, as I drag it down to 15 gallons per minute, put some load on it. That's probably somewhere around 8 to 10 pounds of boost. Maybe not quite that much, maybe 5 to 8 pounds of boost. You could actually pull it and give more boost, but you're not necessarily going to get more horsepower when you get more boost. It's just going to keep, pressurizing that and trying to get as much horsepower as it can. Now, with this, we saw a significant increase in horsepower compared to at least the 540. And you'll see here shortly as we come in, hopefully. Oh, there we go. I got, I want to say it was like 2,500. Here, we'll see it. Come on, type the buttons. 15 gallons a minute, 2,500. So times that by 0.0007, and we get 26.25 horsepower, which in this comparison, and I don't do the math here right in the video, but in this comparison, we're actually comparing to 17.8 that we got because that's what we got when we pulled it to 15. I'll compare it to 17.3, so it's 26.25 compared to 17.8, and what you end up with is right at about 8.5 to 9 horsepower, and which is about a 50% gain. So pretty significant. That is with about 3 turns out. It does not have the DPF, so it's got the bypass on in this case, and of course we're running stock injectors. I'm not saying you couldn't get more horsepower out of this. You can definitely get a lot more horsepower out of this engine, but with what we're doing with it, with just adding some fuel and adding some pressurized air, if you buy this and you get one, you'll get the sense. It's not something that you would want to run 26 horsepower and mow an entire field, like put a 8-foot finish mower on and try to go mow it and just lug it. That's not going to work, and it's probably going to get pretty hot. You add more fuel, it definitely warms up on you. Now, that's the exciting part. A little over 8 horsepower gain, 50% gain. I think that's going to make most everybody very happy, and I believe it's going to be very reliable power. Again, you could do things like change timing, add different injectors, and really increase your boost. But that's not really what we're looking for. That's not the intent of this kit either. It's really to give you that extra oomph going up hills, running MCSs, mowing. When you hit something, I don't know what I'm showing you there, but and then you blow through it, and then you get back to more of a normal operating range. So that's it for the 1025R. Now we're going to jump over to the 2038, and that's where it gets really exciting, at least for me. So I mentioned earlier we were going to go back to the Kubota, and we jumped straight into it, pulling it down to 15. I wanted to go back to the Kubota because it was the first one. I thought, well, maybe the fluid temp being a little warmer for the other ones actually made a difference, and the horsepower that it made. And as you can see here, I've got it pulled down to 15. I even pulled it a little bit lower just to make sure that we didn't get or that we got it down to where we expected. And this did not turn out how I thought. I thought pulling it down to 15, like on the other two tractors, would at least yield a little bit more horsepower. It actually yielded less horsepower. So it's 15.22. I think it was 15.75 before. So I don't have a good answer as to why the Kubota seems to be a lot less than at least what they report on the website. Now, one thing that is at least peculiar is tractor data, which kind of covers all of this data, and is actually, I liked it sourced better than even the websites, for Deere or Kubota. They don't report a PTO horsepower for the BX2380. So I don't know if that's because they have done some tests and had some readings that were didn't match what the website said. Not sure. But for now, it looks like the Kubota is quite a bit less than the 1025R. So here's the 2038R. Did kind of a shotgun version on this one and decided I was just going to pull it down to 15. But I'll tell you, this is the one that's most peculiar to me because similar to the HydrosPlus Turbo Plus, I got a much lower reading at 540 than I expected. Now, I did this a little bit earlier, um, but see, you can kind of see there, so about 1400 times the 1700. We'll hold on to that for just a minute because as I'm pulling it down to 15, and it's right about here that my life flashes before my eyes. You can't hear it because I'm doing the voiceover here, but the chain that I was using gave loose and lots of flailing and slapping and me trying to figure out where the PTO button was. The camera just turned off. I think it knew there was trouble and it just bailed on me. But I didn't turn the camera off, not intentionally at least. I was dancing. Um, so that was the last test for the day. But if you were to go back and look, and I've done that for you, the interesting bit here is that the 2038R wide open throttle uh, pulled down to 15 gallons per minute, which is what we did with the 1025R as well as the other two tractors. It wasn't quite at 2400 psi, which is what the 1025R was, when we pulled it down to 15 gallons per minute. So I mentioned earlier that Tractor Time with Tim said that he's got his Johnny X named 1038R. Uh, I would say that's pretty accurate. Now, regardless of what the horsepower is that we're seeing at the PTO and these different dynos, um, if you're putting the same horsepower to the PTO, then that would suggest maybe the flywheel horsepower is the same. And right now, we are the same as my 2038R. Now, I will over time be able to use this same methodology and this same power comparison apparatus on other tractors, and we can get it dialed in and make sure that we're getting the numbers exactly right. The one that I can actually get behind the Kubota being only, 15 or 16. I say that it's a smaller displacement engine. And maybe it's just the one that I have, but it's not off that far. The 2038R, that's off quite a bit. And so, because you'd be at roughly 26 horsepower, and I think they claim 30. I would have to run the percentages to see if that's a whole lot more than the 15 and the 17. So maybe it actually is on par with kind of what we saw with the Kubota. But yeah, I don't know. I don't have enough testing on this. I do know that this methodology is a sound methodology, and certainly for comparing the power. So whatever the number is, whatever you want it to be, just know that you get about 50% more if you go with Hydros Plus Turbo Plus. And of course, that is on the top end. I'll be using this same machine once I get it rehabilitated to do comparisons at other RPMs with the DPF, with the bypass, different fuel screw settings, and possibly in the future, maybe we'll go a step further and we'll change some timing or add some additional injectors and see what we can come up with until pistons, shoot into outer space. But that's it for this video. I know this format's a little bit different, and you spent some time looking at just a same screen, or you've spent some time looking at my hands not matching up to my voice. I felt like this really was the best format to get the time down. So we'll give it a try. Let me know in the comments if you think this is okay. I tend to listen to a lot of videos on YouTube while I'm driving, so I'm not actually looking at them. So for me, this would work out good, but that's not going to be good for everybody. And if more people don't prefer it, I'll try to do a better job. I am catching up, and I'm behind on a lot of things. So this also helped me get this video done just a little bit quicker. So again, thanks for watching, and if you have questions or comments, just leave them below.